Hi students, let us see today a theorem called Betti's law. This is also called Betti's Maxwell reciprocal theorem. Okay, Betti's law or Betti's Maxwell reciprocal theorem. The statement, let us see the statement first. The virtual work done by P4 system in going through deformation of Q4 system is equal to virtual work done by Q4 system in going through deformation of P4 system. Let us read it once again. The virtual work, okay, you know what is meant by virtual work. Virtual work is load into the deformation, load into actual work into the imaginary displacement or imaginary load into actual displacement. That is virtual work. So the virtual work done by P4 system in going through deformation of Q4 system. P4 system means loads P1, P2, P3, etc. And Q4 system means loads Q1, Q2, Q3, etc. So the virtual work done by P4 system in going through deformation of Q4 system is equal to virtual work done by Q4 system in going through deformation of P4 system. Let us see the notations. WE is external work done when system of forces P is applied. WE dash is external work done when system of forces capital Q is applied. Okay, system of forces capital Q, you can see Q1, Q2, Q3 in the figure. And then a system of forces P1, P2, P3, that is called system of forces P. Then capital Y1, capital Y2, capital Y3. What is that? That is the deformation coming when P1, P2, P3 is applied at the points where later Q1, Q2, Q3 is applied. Okay. And what is small y1, small y2, small y3? Small y1, small y2, small y3 are the deformations coming when loads Q1, Q2, Q3 are applied. And small y1, small y2, small y3 are the deformations which come at the point where P1, P2, P3 are to be applied. Okay, you can see here Y1, Y2, Y3 is the deflection caused by system of forces Q1, Q2, Q3 at point of application of P1, P2, P3. And these are capital Y1, capital Y2, capital Y3. You can see in the figure where P1, P2, P3 is applied. What is that? What is capital Y1, capital Y2, capital Y3? That is nothing but deflection caused by a system of forces capital P1, capital P2, capital P3 at point of application of loads Q1, Q2, Q3. Let the structure be first loaded with system of forces P1, P2, P3. Then work done on the structure is equal to WE. We have taken this notation earlier. As the structure is carrying this system of forces, let the forces Q1, Q2, Q3 be applied. So the total work done is WE plus WE dash. WE dash is the external work done when Q1, Q2, Q3 is applied. Okay, WE plus WE dash plus P1 by 1, P2 by 2 plus P3 by 3. Sorry, total work done equal to WE plus WE dash plus P1 small y1 plus P2 small y2 plus P3 small y3. Let us see the notations once again. Here WE is external work done when system of forces P is applied. WE dash is external work done when system of forces Q is applied. So when Q is applied, WE dash. Okay. So here we are taking first the structure. First the structure is loaded with the forces P1, P2, P3. So the work done first is WE. After that, on that itself, Q1, Q2, Q3 is applied. Okay. So the total work done is WE plus WE dash plus P1 small y1 plus P2 small y2 plus P3 small y3. Let us see the figure once again for clarity. We are doing like this. First, we are giving loads P1, P2, P3. Okay, then we are applying Q1, Q2, Q3. So when Q1, Q2, Q3 is applied, then the deflections Y1, small y1, small y2, small y3 comes. Okay, so the total work done is WE plus WE dash plus P1 small y1 plus P2 small y2 plus P3 small y3. Now we will be taking the order of loading in the reverse order. Let us change the order of loading. Okay, let the structure be first loaded with system of forces Q1, Q2, Q3. So as per our notation, work done on the structure is equal to WE dash. Okay, as the structure is carrying this system of forces, then let us apply P1, P2, P3. Okay, so first the Q1, Q2, Q3 is loading is already there. On that we are applying P1, P2, P3. So what is the total work done? Total work done is WE dash plus WE plus, you can see the figure once again. Let us take the figure once again. So when Q1, Q2, Q3 is applied, work done due to that is Q1 into deflection coming on the direction of Q1 is capital Y1, Q1 capital Y1 plus Q2 capital Y2 plus Q3 capital Y3. Okay, so when the order of loading is changed, our work done becomes WE dash plus WE plus Q1 capital Y1 plus Q2 capital Y2 plus Q3 capital Y3. Okay, as you can see here, Q1 capital Y1 plus Q2 capital Y2 plus Q3 capital Y3. Now let us equate the expressions. The first we have written an expression when loads P1, P2, P3 is acting, and after that Q1, Q2, Q3 acts, and then we have changed the order of loading, and we have written the expression when first Q1, Q2, Q3 is acting, and after that P1, P2, P3 is applied. Anyway, since the loadings are the same, the expressions that we are getting at last should be equal. So WE plus WE dash plus P1 small y1 plus P2 small y2. Here it is P1 small y1 actually. P1 small y1 plus P2 small y2 plus P3 small y3 is equal to WE plus WE dash plus Q1 capital Y1 plus Q2 capital Y2 plus Q3 capital Y3. Okay, so WE plus WE dash is the same on both sides of equation. It cancels out. What you are getting at last? P1 small y1 plus P2 small y2 plus P3 small y3 equal to Q1 capital Y1 plus Q2 capital Y2 plus Q3 capital Y3. Therefore, virtual work done by system of forces P1, P2, P3 due to deflections caused by system of forces Q1, Q2, Q3 equals virtual work done by system of forces Q1, Q2, Q3 due to deflections caused by system of forces P1, P2, P3. So that is the proof of Betti's Maxwell reciprocal theorem. Okay. Small y1, small y2, small y3. What is that? That is the deflection caused by system of forces Q1, Q2, Q3. So P1 into small y1 plus P2 into small y2 plus P3 into small y3. That is equal to capital Y1, capital Y2, capital Y3. What is that? That is the deflection caused by system of forces capital P1, capital P2, capital P3. So Q1, Y1, Q2, Y2, Q2, Y3 is the virtual work done by system of forces Q1, Q2, both Q3, and both are equal. So that is the proof of Betti's reciprocal theorem, or Betti's law, or Betti's Maxwell's reciprocal theorem.